Hi everyone, a very good morning to all. Now we are going to discuss about the question number 89 regarding radioactivity, law of radioactivity. So, all the elements with mass number greater than 170, they are unstable, and those we call it as radioactive elements. So radioactive elements means most unstable, most unstable, and they try to undergo decay to become stable, to become stable. So those elements we call it as radioactive element, and that process we call it as radioactive decay, and there is a law for the radioactive decay. So what is the law? See here, let at t equal to 0, number of atoms are n naught. So for any radioactive element, for any radioactive element, let's take there are n naught number of atoms are there initially. All are now undecayed. Now they start decaying, and after after a time t, the number of atoms undecayed, if it is n, then what is it? Rate of decay dn by dt is proportional to minus n. This dn by dt only we call it as A, that is activity or radioactivity. So that dn by dt equal to minus lambda n or A equal to minus lambda n. Why minus? Because the n value keep on decreasing, because one by one atom undergoing decay process. So undecayed number keep on decreasing. So to represent that we keep this minus sign, and lambda is called disintegration constant. And if you go for integration, like dn by n equal to minus lambda dt, then n you will get n naught into e power minus lambda t. So the number of atoms undecayed after time t, and number of atoms decayed, number of atoms undergone decay process, decayed equal to, let's take n dash is, that is n naught minus n. So similarly, you can also make the equation that initially A naught equal to lambda n naught, and after some time A equal to lambda n. So that you can make the formula A equal to A naught into e power minus lambda t. So this way you can understand the basic formula of law of radioactivity. Now, after time t, you can make one shortcut formula that n by n naught equal to m by n naught equal to a by a naught equal to 1 by 2 whole power n, where n is equal to t by t half, where t half is called half-life. Now, what is half-life we need to understand. What is half-life is, half-life means time to reduce number of undecayed to half of its present value. Like initially n naught, now the number should decrease to n naught by 2. The time taken is called half-life. Then it should become n naught by 4. That is called half-life. Like that, from any number, suppose n naught by 5 is there at one instant, it should become n naught by 10. Then the time taken is called t half. And that t half formula will come log 2 base e by lambda, or 0.693 by lambda. Now mean average life of all the atoms is called mean life. that is tau we represent, that is just 1 by lambda. So 1 by lambda means T half by 0.693 or log 2 base E. So this is the formula of half-life and mean life. So based on these things, usually they will ask the questions. Let's see the examples based on this thing, like how they will ask the questions. The first thing, the half-life of radioactive radon is half-life they have given as 3.8 days. The time at the end of which 1 by 20th of the radon sample will remain undecayed. Now undecayed after some time is 1 by 28th. That means N naught by 20. Now N by N naught equal to 1 by 2 whole power N, or else N equal to N naught into E power minus lambda T, where N is N naught by 20 equal to N naught into E power lambda T. So N naught cancel. Now 1 by E power minus lambda T equal to 20. So E power lambda T equal to 20, because if you take to numerator it will become plus power. Then log you apply, log of E power lambda T base E equal to log 20 base E. So here lambda T will become multiplier, log E base E equal to log 20. So log 20 I can write it as log 10 base E plus log 2 base E. Now base E, if you convert it into, this will become 1. So lambda T equal to base E, if you want to convert to base 10, 2.303 have to multiply. Then log 10 base 10 plus log 2 base 10. Now this will become like lambda T equal to 2.303 log 10 base 10 1, log 2 base 10 is 0.3010. Now here they have given T half, not lambda. So it will become like T equal to 2.303 into 1.3010 into 1 by lambda, where T half is 0.693 by lambda. Then 1 by lambda can be replaced as 0.693 by T half. So if you substitute that value, then you will get the T value. So this is how you have to apply. Sometimes in the questions logarithmic and integration, sometimes all those things. So mathematics will come. So you have to take those that equation properly, and you have to understand the condition. What is they are telling, like whether undecayed percentage they have given or decayed percentage they have given. Then you have to make the proper equations. Now the next thing is, a sample contains 16 grams of radioactive material, the half-life period of which is 2 days. So half-life is 2 days. And after 32 days, after a time of 32 days, the amount of radioactive sample left is. So initial mass is 16 gram. Now m by m naught equal to 1 by 2 whole power n you can take, where 1 by 2 whole power n means T by T half. So 1 by 2 whole power T is 32 days by 2. So it will become 1 by 2 whole power 16. Now 1 by 2 whole power 16. Now it will become like, see, 1 by 2 whole power 4 whole power 4 I can write. So that 1 by 2 whole power 4 means 1 by 16 whole power 4. So the value will become very less. So not 1 by 4, 1 by 2, it is even very, very less. So suitable option you can take less than 1 gram, but you cannot specify. Your options are not suitable because m naught is 16. So it will become like 1 by 16 into 16 into 16, very, very lesser value. So simply you can take less than 1 milligram. Now, the next thing is the activity of a radioactive element decreases to 1/3. So initial at t equal to 0 A naught, then after time t it will become A equal to A naught by 3, 1/3, decrease to 1/3. Here A naught they are mentioning as I naught, so no problem, in a period of 9 years. In a time of 9 years, after a further lapse of 9 years, its activity will be. So now see here, first A equal to A naught into e power minus lambda t when you consider. Now here A became A naught by 3 in a period of minus lambda t. T1. T1 is 9 years. So that 1 by 3 equal to e power minus lambda 9 years. So 9 you substitute it e power minus 9 lambda. Now after a further lapse of 9 more years. Now 9 more years means after time 18 years we have to take. Then A will become A naught into e power minus lambda t is now 18. Now A equal to A naught into e power minus 18 lambda. This I can write it as, see, A naught into e power minus 9 lambda whole power 2 I can write. So that 18 lambda it remains. So A equal to A naught into e power minus 9 lambda is 1 by 3. 1 by 3 whole square is A naught by 9. That means according to the question, I naught by 9. So it will become 1 by 9th of the initial value. Now, a radioactive element A with a half-life period of 2 hours decays giving a stable element Y. After a time T, the ratio of X to Y atoms is 1:7. Then T is. C is. Now X is becoming into Y. Now initially at T equal to 0, Nx is to consider N0 and Ny is how much? 0. Now after time T, Nx will become N0 e power minus lambda T actually. Or you can take it in this manner also. Nx by N0 equal to 1 by 2 whole power N. N is T by T half is 2. Like this also you can take. Now Nx will become N0 into 1 by 2 whole power T by 2. Now these many undecayed. That means how many decayed? N0 minus Nx. So the number of atoms decayed will become into Y. So here indirectly number of Y atoms nothing but number of X atoms decayed. Number of atoms decayed means what? Total minus undecayed, N0 minus Nx. Now they are telling that Nx by Ny after time, that is N0 into 1 by 2 whole power or N0, N0. Let's take just Nx first. So Nx by Ny is N0 minus Nx. Now this will, I can write it as 1 by N0 by Nx minus 1 equal to 1 by N0 by Nx means 1 by 2 whole power 1 by 1 by 2. See here the calculation is becoming little bit lengthy, or else you do one thing. See here Nx is n naught into 1 by 2 whole power t by 2 by ny is n naught minus nx. Nx is n naught into 1 by 2 whole power t by 2 equal to n naught if you take common it will get cancelled 1 by 2 whole power t by 2 by 1 minus 1 by 2 whole power t by 2. Now this is equal to 1 by 7 they are telling. Now if you equate it, then you will get the value like cross multiplied 7 into 1 by 2 whole power t by 2 equal to 1 minus 1 by 2 into t by 2. Then you bring this side. So it will become 8 into 1 by 2 whole power t by 2 equal to 1. Then I can write it as 1 by 2 whole power t by 2 equal to 1 by 8. So here now 1 by 8 I can write it as 1 by 2 whole power 3. So then it will become both sides the base is same. Then the power also must be same. Then it will become t by 2 equal to 1 by 2 whole power 3. That means power 3. So t will become 6. So that way you need to understand. So here the calculation became little bit lengthy and tough, but sometimes they can give such kind of questions. As I said, logarithmic can be applied, powers and all. So you have to take care of calculation. Now the next one, last and final question. If 10% of a radioactive material decays in 5 days, then the amount of the original material left after 20 days is. See, n equal to n naught into e power minus lambda. Now n is 10%. 10% means 10 by 100 when time is 5 days. Now, then the amount of the original material left after 20 days is approximately. Now n dash let's take, or n you consider, n equal to now n naught into e power minus after 20 days. So from the first equation we get that e power minus 5 lambda equal to 1 by 10. Now here n equal to n naught into e power minus 20 lambda, I can write it as e power minus 5 lambda whole power 4. So that n naught into e power minus 5 lambda is 1 by 10 whole power 4 equal to n naught into now 10%. Okay. Now n naught into 1 by 10 whole power 4 means 1 by 10,000. See here I have done one small mistake. See the thing is 10% decayed. Here n is undecayed we have to take. That means 90% undecayed. So that it will become 9 by 10. So that here we will substitute 9 by 10. So that here 9 into 9 into 9 into 9. So now it will become n by n naught equal to 81 into 81 by 10,000. Now if you want percentage undecayed means you have to multiply with 100. That means 81 into 81 by 100. So 80 into 80 approximately you take. Percentage means now you can take it like C. N by n naught equal to 80 into 80 if you take approximately 6,400 or approximately you take 65,000. Sorry 6,500 by 10,000. Now n by n naught into 100% means it will become 6,500 by 100. So approximately it will become 65%. Approximately I calculated. So that you will get the answer like this. So this way you need to understand and you need to calculate the question. So one of the important topic. So please try to understand and try to solve. So similar questions I have given as an assignment. Try to solve them first. And NCERT based questions also there. See, lot of questions are there. 6 questions they have given based on the same thing. So please try to practice each and every question. Thank you. We'll continue in the coming session with the next question.